In our lecture today, we're going to learn the quotient rule. Now, as we'll see, the quotient rule is just a special case of the product rule. And when you have a quotient rule question, technically you can always use the product rule to solve for the derivative, though sometimes using the quotient rule leads to simplification. So the quotient rule is useful whenever you want to take the derivative of a product, or not a product, a ratio of two functions. So suppose you have a function, let's say y is equal to f of x divided by g of x. So we have one function on top, so we'll call this the top, and then this function is on the bottom. So the quotient rule tells us how to take the derivative of a ratio of two functions. And it literally just says this, that the derivative of the ratio is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So if we write that out, we get the bottom times the derivative of the top, so g of x times f prime of x, and then minus the top times the derivative of the bottom, and then all divided by the bottom squared. So this is exactly the quotient rule. So this is the quotient rule. So the product rule will tell you how to take the derivative of a product of two functions, and the quotient rule tells you how to take the derivative of the ratio of two functions, f of x divided by g of x. Notice it's the bottom function, and I like to think bottom times the derivative of the top, and then minus the top times the derivative of the bottom. So you start on the bottom, multiply by the derivative of the top, and then subtract the top times the derivative of the bottom. The order matters because of this minus sign. If you get it backwards, if you say the top times the derivative of the bottom, if you start that way, then you're subtracting the wrong one, and you're going to basically pick up a minus sign. So it's always important to do the bottom times the derivative of the top, and then minus the top times the derivative of the bottom, all divided by the bottom squared. Now, to see where this comes from, we can apply the product rule, and we'll use the chain rule along the way. So to derive this formula, suppose we have y is equal to f of x over g of x. Now this is the same as f of x times 1 over g of x. Right, so dividing by a number is the same as multiplying by its reciprocal. So if we divide by g of x, it's the same as multiplying by 1 over g of x. So you can see right away how you can use the product rule here, because we basically have now a product of two functions, the first function being f of x, and the second function not being g of x, but 1 over g of x. So our first function is f of x, and our second function is 1 over g of x. So to take the derivative, right, remember we have two terms added together, and one term will be the derivative of one factor times the derivative, or one factor times the derivative of the other factor, and then the second term will be the other factor times the derivative of the one factor. So you just, one of the terms that you do the derivative of the first factor, and the other term you do the derivative of the second factor. So let's start with writing the derivative of the first factor. So this is going to be f prime of x, and then times the second component. So it's f prime of x times 1 over g of x. And then plus this, then this one times the derivative of the other one. So it's going to be plus f of x, and then times the derivative, so I'm not going to simplify it yet, but the derivative of 1 over g of x. So we have f of x, so this is basically the first times the derivative of the second, and then plus the second times the derivative of the first. So I just kind of reverse the ordering for a moment. You might see in a second. So here we have to figure out now how to take the derivative of 1 over g of x. Well, to do that, we rely on the chain rule, because 1 over g of x is really just g of x raised to the minus 1. Right? So let me make a note up top. So 1 divided by g of x is just equal to g of x raised to the minus 1. How do we take the derivative of that? Well, the minus 1 comes down, we subtract 1, making it a minus 2, and then we multiply by the derivative of the inside. So continuing this line, we have dy dx is equal to f prime times 1 over g of x plus f of x times the derivative of 1 over g of x, and that's equal to this first term I'm just going to simplify and write as f prime of x divided by g of x. And then here we have plus f of x times the derivative of g of x to the minus 1. So the minus 1 comes down, and that minus 1, when it comes down, it's going to change this plus sign to a minus sign. So let me change this to a minus. So that's the minus 1 from the exponent. And then we have g of x. The new exponent is a minus 2. So this previously was g of x to the minus 1. The minus 1 came down and we kicked it down to a minus 2. And then we multiply it by the derivative of the inside, g prime of x. I'm going to rewrite this again. Now the first term I'm going to write as f prime of x times g of x divided by g of x squared. And then minus what we have here is f of x times g prime of x divided by g of x squared. Now notice on the first term I added a factor of g of x over g of x. So I multiply by g of x over g of x in order to create a common denominator of g of x squared. On the second term, the g of x to the minus 2, the minus sign I used to create the reciprocal, so it's 1 divided by g of x squared. And then we can combine these two and write f prime of x g of x, so this is the bottom times the derivative of the top, and then minus the top times the derivative of the bottom, and the whole thing is divided by the bottom squared. So the quotient rule is really nothing new, even though it is a new formula, and the formula is easy, or it's useful at times to when you have a quotient of two functions given to you. Sometimes it's easier to just go through this formula than to rely on the product rule coupled with the chain rule, because you have automatically a product rule and a chain rule. And if you have to use the chain rule to compute g prime of x, then you're using a chain rule inside of a chain rule. So here it just tells you straight out, it's the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Bam, you're done. You just have to follow this formula and put the things in proper place. So if you forget this formula, it just comes from the product rule and the chain rule, so you can always derive it.